Chlorine is a chemical element with symbol Cl and atomic number 17. It has a relative atomic mass of about 35.5. Chlorine is in the halogen group, 17, and is the second lightest halogen, following fluorine. The element is a yellow-green gas under standard conditions, where it forms diatomic molecules. Chlorine has the highest electron affinity and the third highest electronegativity of all the reactive elements. For this reason, chlorine is a strong oxidizing agent. Free chlorine is rare on Earth, and is usually a result of direct or indirect oxidation by oxygen. The most common compound of chlorine, sodium chloride, common salt, has been known since ancient times. Around 1630, chlorine gas was first synthesized in a chemical reaction, but not recognized as a fundamentally important substance. Characterization of chlorine gas was made in 1774 by Carl Wilhelm Scheele, who supposed it to be an oxide of a new element. In 1809, chemists suggested that the gas might be a pure element, and this was confirmed by Sir Humphry Davy in 1810, who named it from ancient Greek, chloros, pale green. Nearly all chlorine in the Earth's crust occurs as chloride in various ionic compounds, including table salt. It is the second most abundant halogen and 21st most abundant chemical element in Earth's crust. Elemental chlorine is commercially produced from brine by electrolysis. The high oxidizing potential of elemental chlorine led commercially to free chlorine's bleaching and disinfectant uses, as well as its many uses as an essential reagent in the chemical industry. Chlorine is used in the manufacture of a wide range of consumer products, about 2/3 of them organic chemicals such as polyvinyl chloride, as well as many intermediates for production of plastics and other end products which do not contain the element. As a common disinfectant, elemental chlorine and chlorine-generating compounds are used more directly in swimming pools to keep them clean and sanitary. In the form of chloride ions, chlorine is necessary to all known species of life. Other types of chlorine compounds are rare in living organisms, and artificially produced chlorinated organics range from inert to toxic. In the upper atmosphere, chlorine-containing organic molecules such as chlorofluorocarbons have been implicated in ozone depletion. Small quantities of elemental chlorine are generated by oxidation of chloride to hypochlorite in neutrophils, as part of the immune response against bacteria. Elemental chlorine at high concentrations is extremely dangerous and poisonous for all living organisms, and was used in World War I as the first gaseous chemical warfare agent. Physical characteristics of chlorine and its compounds at standard temperature and pressure. 2 chlorine atoms form the diatomic molecule Cl2. This is a yellow-green gas that has a distinctive strong odor, familiar to most from common household bleach. The bonding between the two atoms is relatively weak, only 242.580 plus minus 0.004 kilojoules per mole, which makes the Cl2 molecule highly reactive. The boiling point at standard pressure is around -34 C. But it can be liquefied at room temperature with pressures above 740 kilopascals, 107 pounds per square inch. Elemental chlorine is yellow-green, but the chloride ion, in common with other halide ions, has no color in either minerals or solutions, example, table salt. Similarly, again as with other halogens, chlorine atoms impart no color to organic chlorides when they replace hydrogen atoms in colorless organic compounds, such as tetrachloromethane. The melting point and density of these compounds is increased by substitution of chlorine in place of hydrogen. Compounds of chlorine with other halogens, as well as many chlorine oxides, are colored. Chemical characteristics, along with fluorine, bromine, iodine, and acetine, chlorine is a member of the halogen series that forms the group 17, formerly 7, Vea, or Vb, of the periodic table. Chlorine forms compounds with almost all of the elements to give compounds that are usually called chlorides. Chlorine gas reacts with most organic compounds, and will even sluggishly support the combustion of hydrocarbons,